morning, everyone. So now today I'm going to present the hierarchical divisive clustering algorithm. So we are going to discuss about hierarchical clustering algorithm. My name is Karthik Reddy. So let's start the presentation. So this is the video blog I am doing about the hierarchical divisive clustering algorithm. And let us first discuss what is a hierarchical divisive algorithm. So there are many cluster algorithms. So hierarchical divisive is one of the type of clustering algorithm. So in this clustering algorithm, whatever the data objects are present, they are grouped in a top-down manner, in a ladder manner. You can say in a ladder manner, top-down manner. So that these data objects are grouped in a top-down manner. Initially, all objects are in one cluster. So initially, at the starting stage, all the objects are in one cluster. So we are dividing the clusters. We are dividing the objects into different clusters. Initially, they are all in one cluster. Then after that, the cluster is subdivided into smaller and smaller pieces. The cluster, whatever we are going to is present in that the starting stage is we are going to divide into small pieces until every object become forms a cluster on its own, and or until it satisfies the certain termination conditions and as desired number of clusters is obtained. So where we start dividing the initial state cluster into subparts, so small pieces until when the every object is divided into a single cluster. So every object is divided into a single cluster, and or until we meet a certain criteria, to the termination criteria to stop the clustering algorithm. So this is the algorithm about divisive clustering, hierarchical clustering algorithm. It is a top-down manner, like a ladder manner, and all objects initially are in one cluster. In a single cluster, all the objects are in there. Then after that, we are going to divide that single cluster into parts, and we are going to make them until we reach the satisfactory state. So what is the divided algorithm we use is, so we there are many divisive algorithm, hierarchical divisive algorithm. One approach is that using minimum spanning tree. So what we do is we compute a minimum spanning tree from the given adjacency matrix. So we compute a given whatever the tree is there, whatever the cluster is there, we turn into that into a minimum spanning tree. So what is a minimum spanning tree? We can see what is a minimum spanning tree. The minimum spanning tree is nothing but forming a relations between the nodes with a minimum, so that the traveling going from one node to another gives a minimum cost. So now we create a new cluster after forming the minimum spanning tree. We create a new cluster by breaking the link corresponding to the largest distance. So why we find the largest distance that is having in the minimum spanning tree, and we break that first distance. Wow, and we repeat this process by breaking the largest distance and breaking the largest distance until we reach a single clusters remain. So until every object has its own cluster, we will break down the largest distance edges of the cluster present, of the minimum spanning tree present. So then we can continue this process until we meet a certain criteria, which is our satisfactory criteria. So let's see an example. So an example is that, so this is the adjacency matrix. So adjacency matrix is nothing but whatever the objects are there. If there, I mean, if the B, B, C, D. So adjacency matrix, what is gives the distance between the two nodes. So A distance is 0, B distance. So A distance is 1, B distance is 0. So BC distance is 2. So that gives the distance between two nodes. So the edge, what is the edge cost? It gives the edge centimeter. So this is the minimum minimum spanning tree. So we form the minimum spanning tree from the edge centimeter, and then this table gives the what you can see this table. Here the edges are there. A, B, those are the edges, and the cost between those edges. So we from this table we create this tree, minimum spanning tree. So and then like that. So what we have to do now after forming the minimum spanning tree? So what we have to do is we have to find the largest edge. As I have discussed in algorithm, we have to find the largest edge and break down that edge. So the largest edge is AE, we break down the edge E, AE. So the clusters, two clusters are formed. So A, C, B, D is a separate cluster, E is a separate cluster. Here we can see that E is a separate cluster, A, B, C, D is a separate cluster. Next, what is the second largest? The next largest in the cluster A, B, C, D. So in the cluster A, B, C, D, AC is the largest with a value 2. So now we remove the edge AC. So now that there are three clusters formed. So one is the before A, E, and then the cluster AB, and then the cluster CD. Now the three clusters are formed A, B, C, D, and E. So now we have to continue this process until how all the objects have their own cluster. So every single object should have their own cluster. So that cluster is, then what is the next largest? Next largest is either AB or CD. You can break both any of them. So let's break AB. So after breaking AB, what we have four clusters: A, B, C, comma D, and E. These are the four clusters. So now we should continue the process because CD is not a single cluster. So now the next we have to break is CD. Now after breaking the CD, we have five clusters. What are those? A, B, C, D, E. These are the five clusters we have formed. So this is the we achieved the singleton cluster. So this is okay. Now the uh, so so the so what we have to do, another example, another type of example is so this is another example. So this is the adjacency matrix, and then this is the edge cost and minimum symmetry we have chosen. So this is the minimum symmetry from the adjacency matrix. From this is the adjacency matrix column, and this is the refined means minimum span tree. So from that we have formed the minimum span tree. This is another example. So the process here is first. This is the starting stage of the minimum span tree. So what is the largest here? 1614 is the largest with a weight of 6. So with the edge weight of 6 we have to break 14 so that the cost having 6, so that after that the cluster is the cluster looks like this. So we have break in 1 4. So there are two clusters formed, 2 comma 4 and 1 3 5. Two clusters have formed. Now what we have to break next highest is we have seen here 5. So two we have to break 2 comma 4. So three clusters have formed, 2 4 1 3 5. So what is the other cluster? Here we can see 2 4 1 3 5 is the clusters. But we have to continue the process since 1 3 5 is not a singleton cluster. So here 1 3 5 is not a singleton cluster. Next, so what we have to break? We have to break next largest is 1 3. So 1 3 is the largest with the weight 3, with the cost 3. So we have to break 1 3. So after breaking 1 3, we can get the tree like this. So we have four clusters now. 1 2 3 comma 5 and 4. 1 2 3 comma 5 and 4. These are the four clusters now. Still we have to break because 3 comma 5 is not a singleton cluster. So we have to break the 3 comma 2 by having cost 2. Now the 5 clusters are formed 2 4 1 3 5. So this is like the another example. The example. So this is the step by step this is a step by step process. So like that only. So here is another example for you. So here A B C D E they are given, and with the edge cost AE 3, AC 2, AB 1, CD 1. So this is the minimum spanner tree that was given. So now what we are doing here first what is the largest one, that is the highest one is AE. So here we have breaken AE. So now the clusters are from A, B, C, D and E. So these are the two clusters. Next what is we have to break AC, we have to break because here is two value, AC will break, and like this will come, we got three clusters A, B, C, D and E. So now what we can either break AB or CD. So we are going to break AB. So after breaking AB, we have formed four clusters A, B, E, CD. CD is not a single cluster. So we have to break the CD also A, B, C, E, D, E. So this is the breakdown. After this is the, so you can see here initially another example here. Initially like this is there. This is the initial state. After breaking down, this happened. So the cluster and we have clustered all the nodes, whatever are the data objects are there. So here is another example for you. So we have here four nodes, one, two, three, four. So from the adjacent matrix like 3 comma 3 is to 4 5, 3 is to 4 6, 2 is to 3 9, 1 is to 4 9, 1 is to 3 10, 1 is to 2 11. So from this adjacent matrix we have found the minimum cost minimum spanning tree. So that minimum spanning tree is that 3 is to 4, 2 is to 4, 1 is to 4, 5 6 9. So now we have drawn the minimum spanning tree from the adjacent matrix in an ascending order of their cost. So wait a minute. So we are doing the minimum spanning tree. But what is the minimum spanning tree method? What method you are using? Kruskal's method. So Kruskal's is one of the method to form the minimum spanning tree. So one is the like Kruskal's method we are using. What is the Kruskal's method? We have to sort the ascending. We have to arrange the edges, all the edges in a ascending order, so that we can get the minimum cost from those. So like this, the minimum spanning tree is formed. So after that, what we have to do, we have to break down the largest edge. So what here is the largest edge? 1 comma 4 is the largest edge having cost 9. So there are two clusters formed 2, 3, 4 and 1. 2, 3, 4 and 1. So like this clustering is formed 1 and another cluster is 2, 3, 4. So we have to break next highest bridge edge. That is 6. We are breaking the 6, 4, 5, 4, 2. And then we have got three clusters 1, 4, 4, 4 and 3 and 2. So these are the three clusters. After that, whatever the remaining is there 5. So we are breaking down the 5. So break down the edge 3 comma 4 having cost 5. The four clusters are formed now 1, 4, 2, 3. So these are the final clusters, 4 clusters. We can stop the process now because we have no edges to break. So that is uh, the minimum chain entry hierarchical device clustering algorithm. So hierarchical device clustering algorithm is nothing but we have the data objects. We have to break down them into clusters. So what we do is that we form a minimum spanning tree. So forming a minimum spanning tree is a simple basic approach. So that approach we have discussed in this video. So we have to form a minimum spanning tree and then we have to break down the largest edge. Largest distance means largest edge in the minimum spanning tree. So after we have to continue this process by breaking down the largest edge until we get this until we meet this satisfying category or until we form until we get the singleton clusters. So until we get the singleton clusters, we can say that. So we have discussed some examples like in this example first we are going to break down A and E. So that is the largest one, and then we can break down A and C. So that is another one. So we will break down like this, and we will form the clusters. So this approach we have used. So I'm just going to revise again here. So from this, whatever the Kruskal's algorithm, what is the Kruskal's algorithm? Arranging the edges in ascending order of their cost. So whatever we have seen here, this is just edge cost. So in this table you have seen edge cost. So we have to arrange according to the ascending order. We take the smaller ones, so we don't get the larger ones. So whatever we have taken, these three we have taken to cover all the nodes. So in up to here, if we take these three, we can cover these. So the minimum thing we have done 1, 2, 3. So 3 comma 4 we have done 2 comma 4, 2 comma 3 no need, 1 comma 4. So whatever the uncovered no vertices are there, we have to take from the uh, sorted order of edge center 3. So that's it, guys. Thank you very much.